what's going on with the iris and the lenses? Parasympathetic?
Oh,
Parasympathetic?
both.
What's
It's
that?
relax the pupil.
For parasympathetic, it's gonna be
No, parasympathetic constricts.
because you don't need to see as far.
Yeah, for closer vision, and then the sympathetic dilates.
And the lens bulges. The lens bulges. For sympathetic, the lens flattens and the pupils dilate. All right. All right.
So when your lens, can you have your lens flattened and your pupil constricted?
Yeah, you can, because then you're doing bright light,
Right.
but looking up close.
Okay. So like what they're doing.
Yeah,
Okay.
bright light, looking up close. God darn, I'll have to tell them about my batteries. Yeah. And there is another there that they talk about with emotional states
Your
and
chapstick.
sexual arousal and all of that. You end up seeing dilation of the pupils, and that's another thing that ends up being appealing. And that's actually when brown eyes can be more appealing than blue eyes, because the darkness of the eyes is indicating dilation, and it's indicating arousal. So,
For all you
that's
people
one
with blue
thing.
eyes out there.
Oh.
Good luck finding that part.
All right,
No,
so
just kidding.
let's talk about the retina now. The retina, again, is going to be the sensory part of this. And the retina is basically 2 layers. And if you had your book, I would recommend kind of opening it up and looking at it. The outer layer is what allows the light to come in. And this is where you're going to have all of your photoreceptors that are there. Remember that the type of neurons that are found there were bipolar. Do you remember when we looked at types of neurons? These are the only place you see bipolar neurons. So they end up behaving, or it ends up seeing something quite different there. Remember that if you're going to have sensation, you have to have transduction. And what is transduction?
Process of making
Make an action potential. So you have to stimulate an action potential. And so the ganglion cells that are there, that's what's going to be able to stimulate that action potential. So the light reception, then the action potential or transduction occurs, then it's able to transmit through the optic nerve and then go into the brain and start getting processed as vision. You guys got to see the optic disc today, and that is called the blind spot. For the exam, know it as optic disc. So that's the lack of any of those receptors, because the optic nerve has to come in through the back of the eye. You can't have sight where you're having this unit enter in. There's also vessels too that you can end up seeing that enter in through the back of the eye as well. So you don't have any receptors at that point. Now let's look at the 2 types of receptors we have there, and these are looking at sensory or for sight. And remember again that these are photoreceptors, but we have rods and cones. The rods are going to be able to see in dimness or darkness or shadows, and they also see in black and white. Black and white. And this is going to be found more on the outer region of the retina. So again, if you're looking at your book and that's a perfect picture too where you're looking at it. So it's the outer region of the retina is where I guess it would be this way, is going to end up being where you see the rods. And again, all you're going to see are in shades of black and white or grays. That's it. We turn the lights off in here, all the colors are going to disappear, and it's nothing but shades of gray or shades of black and white. The cones, on the other hand, These are gonna be found more centralized, and they're found in a region that's called the macula. We talked the other day about one degenerative disease that is called macular degenerative disease or macular degeneration. And what that's referring to is that the rods are going down, the cones are going downhill. You're actually getting destruction of those cones. That can be from cigarette smoking, excessive amounts of cigarette smoking. That can end up being genetic, can have a genetic link, and sometimes just an age link that you end up seeing with macular degeneration. The most concentrated part of it, and you guys answered this the other day on the handout, which I am going to return to you guys right now, is the fovea centralis. And again, that just ends up being the most concentrated area of cones that you see within the retina. The retina now has to operate under adequate light, really, really good light. That's the way humans end up operating. We don't see colors at night vision. We just see, again, blacks and grays and whites. It's bright light where the cones are going to be stimulated to be able to generate that action potential. Okay, yeah.
So for people with astigmatism, I know they have a lot of sensitivity to light. So is this something to do with the cones?
It has to do with the diffraction and refraction that's going on, either with the cornea or with the lens.
Okay.
And so it is hitting in the back, and again, it's just diffracting the light in a way that they're just not able to deal with it.
Yeah,
And
I just
there
saw-
gives them a sensitivity.
I just saw a video on the eye. Rods actually, for each bipolar neuron there's like, there can be like 100 rods per each.
Oh, yeah.
Yeah, so that's why when you're at night and you wake up and you look around, that's why you see shapes. You don't really see distinctive points. But cones, they get their individual bipolar neuron, which
Isn't
allows
that
you to see
amazing?
vision very acutely.
Acutely, yeah.
So if I'm like, if I was looking at that visualized cell thing for a while, oh, and they get tired too. Cones get tired. So if I was looking at the visualized cell thing for a while, and then I looked at a white board, I'd still be imaging the
Have
visualized
you
cell.
done that before?
Mhm.
Yeah, and you like, and
It's
then you
cool.
still see.